Welcome to The Explainer. Today we're diving into one of the biggest, and kind of sneaky, risks in artificial intelligence. It's a threat that doesn't live in the code you write, but in all the building blocks you trust to create your AI.
So let's just start right there with that exact question, because it gets to the absolute heart of a new, really complex security challenge that pretty much every single organization building with AI is facing right now. We're talking about something way beyond just your algorithms. It's about everything they stand on.
And look, this isn't just some theoretical what if. The OWASP Foundation, that's pronounced OWASP, and they are the global leaders in web security. They rank this as the #3 most critical vulnerability for large language models. So when OWASP says something is that important, you know we've all got to sit up and pay attention.
Okay, so here's our roadmap for today. First, we're going to map out this hidden supply chain and then really unpack the vulnerabilities. After that, we'll get into the scary stuff. What happens when this chain breaks in the real world? Then we'll shift gears, look at the official security playbook, and wrap up by seeing how automation is pretty much the only way to stay ahead of these threats.
All right, first things first. We've really got to get our heads around what an AI supply chain actually is. Because if you're just thinking about traditional software libraries and dependencies, you're honestly only seeing a tiny piece of a much bigger puzzle.
The LLM supply chain is this whole sprawling ecosystem. It starts with the massive pre-trained models we grab from places like Google or Hugging Face, but it also includes all the data we use to train them, those clever little adapters for fine-tuning, and even the platforms where the model eventually runs. Every single one of those is a link in the chain. And yeah, every single one is a potential backdoor for an attacker.
So where exactly can these nasty vulnerabilities hide? Let's break it down into the 3 most critical areas we really need to keep an eye on.
The first, and maybe most obvious link, is the foundation model itself. We tend to download these models and just treat them like a secure black box. But what if it's been tampered with at the source? Or what if its documentation, the model card, is incomplete or, even worse, is flat out lying to you? That's a huge risk right there. And here's the kicker. Even our attempts to customize models open up new doors for attackers. This happens in the fine-tuning layer. We use these small, nifty components called LoRa adapters to efficiently teach a model new skills without retraining the whole thing. It's super efficient, but it also creates a massive new attack surface because a malicious adapter can so easily be slipped in to corrupt a perfectly safe model.
And finally, our third critical area is the data and the deployment infrastructure itself. The very datasets you use for training, they can be poisoned with bad information. The container images you use to run the model, they can have their own set of vulnerabilities. Basically, any piece of infrastructure that even touches your model is now part of its risk profile.
So, what actually happens when one of these links in the chain breaks? Believe me, this is not just theoretical. Let's look at some real-world attacks that show just how devastating the consequences can be.
Let's talk about the Poison GPT attack. Now, in this case, attackers didn't hack a system in the traditional sense. No, they directly mess with the model's internal brain, a process some people call lobotomization. They published this corrupted model specifically designed to get around the usual safety filters, and it could be used to generate incredibly convincing fake news. It just goes to show that the safeguards at the repository level, they're not enough.
Or think about this classic supply chain attack. It's almost exactly what happened in OpenAI's first big data breach. Attackers just uploaded a malicious package to the Python package index, a place developers trust. Developers, thinking they were getting a helpful tool, accidentally installed malware that gave attackers a permanent backdoor into their systems and, of course, their valuable IP.
This next one is just wow. It shows how clever attackers can be. A really popular open-source model called Wizard LM was removed from a repository. What did attackers do? They immediately published a fake, malicious version with the exact same name. So all these teams scrambling for a replacement downloaded this Trojan horse and basically compromised their entire infrastructure, all from one simple act of trust.
So with threats like these floating around, how in the world do we actually defend ourselves? Well, the good news is, OWASP doesn't just point out problems. They also provide a really comprehensive, though I've got to say very demanding, playbook for how to fix them.
The official guidance is all about defense in depth. It means you have to rigorously vet every single supplier and data source. You have to cryptographically verify every model file. You have to create a full inventory of every single component. That's what a software bill of materials, or SBOM, is. And on top of all that, you have to constantly be running tests to poke and prod for new weaknesses. It's a lot.
Now, this playbook is absolutely essential, but let's be real for a second. Trying to do all of this by hand is just a monumental task. It requires this incredibly deep, specialized expertise in both AI and cybersecurity. And trying to do it for every model across your whole company, it creates a massive bottleneck it's nearly impossible to scale.
And that leads us directly to the only logical solution. If the manual approach just can't keep up, we have to automate. And this is exactly where platforms designed for this very challenge come into play, like the VeriGenAI Red Team Platform. That's VeriGenAI.
The real power of automation here is speed and scale. A manual audit of your supply chain, that could take a team of experts weeks, maybe even months. An automated platform like VeriGenAI, on the other hand, can run a comprehensive assessment in minutes. It takes all that specialized knowledge, bakes it right into the software, and makes it available to everyone for any project instantly. The friction is gone.
The whole approach here is to build security in from the very beginning. So step 1, you assess any new component before it ever gets into your system. Step 2, you build automated security checks right into your development pipeline, like a guard at the gate, so nothing vulnerable can ever slip through. And step 3, you continuously monitor your entire supply chain in real time.
And what this automation really does is democratize security. Suddenly, your developers are empowered to run their own quick checks without waiting weeks for the central security team. That security team can now scale their expertise across the whole organization instead of being a bottleneck. Your compliance teams get automated reports, and leadership gets a clear, real-time dashboard showing the company's actual risk. Everybody wins.
So, we've walked through the hidden maze of the AI supply chain, we've seen the very real dangers when it breaks, and we've mapped out the path from a slow, manual, unscalable playbook to a fast, automated, and truly comprehensive solution. And that really leaves us with this one final critical question. As AI gets woven into the fabric of everything we do, the question is no longer if your supply chain has vulnerabilities. The question is, do you have the tools to find that weakest link before an attacker does?